Hello, you're most welcome to today's lesson. Remember the last time we met, we looked at area of parallelogram, and we also looked at area of a rhombus. Now we are going to look at the area of the kite. Area of a kite. We are going to look at area of a kite. We are going to look at area of a rhombus. So we shall first of all begin with finding area, of a rhombus. Finding area of a rhombus. Finding area of a rhombus. First of all, we need to know what a rhombus looks like. So, illustration. How does a rhombus look like? Remember we said a rhombus looks like it is a slanty square. A rhombus is a slanty square. A rhombus is a slanty square. It is a square but slanty. Since we are saying it is a slanty square, that means all its sides are equal. All its sides are equal. Within a rhombus, it has got diagonals, and what I'm drawing are the diagonals. So all the sides of a rhombus are equal. All the sides of a rhombus are equal. All the sides of a rhombus are equal. And the opposite sides of a rhombus are parallel. So this side is parallel to this side. Opposite sides of a rhombus are parallel. This side is also parallel to this side. Now that is a rhombus. These are the diagonals. These are the diagonals. That one and this one are what we call the diagonals. Those are the diagonals. Those are the diagonals of a rhombus. Those are the diagonals of a rhombus. So now, how do we find the area? Area of a rhombus. Area of a rhombus is equal to a half times diagonal 1. Remember, I've said the diagonals are 2. It is area times the length of diagonal 1 times the length of diagonal 2. The formula for finding area of a rhombus is a half times diagonal 1 times diagonal 2. Or another one could be area of a rhombus is equal to diagonal 1 times diagonal 2 out of 2. So you can use any of those two to find the area of a rhombus. Okay, example. I straight away take you to the example. Remember, earlier on we had looked at the properties of a rhombus, and remember we said the diagonals bisect each other at 90 degrees, and they end up forming 4 right angle triangles. Now I'm going to give 3 ways of how we are going to find the rhombus. One, we are going to use the diagonals. We can use the diagonals to find the area. We can use the right angles to find the area. We can use the isosceles triangles to find the area. Now, I'll first of all look at this first example. Calculate one. Example one. Calculate the area. Calculate the area of the rhombus. Calculate the area of the rhombus below. So I've said we are going to find the area using three methods. We are going to use three methods. So what you find that is easier for you is what you will do. Now, this is our rhombus. And we are finding its area. This is our rhombus, and we are going to find its area. Okay, the diagonals, these are the diagonals. These are our diagonals. These remember we said the diagonals of a rhombus bisect each other. They bisect each other at a right angle. In other words, as they bisect themselves, they end up forming four right-angled triangles. This is a right-angled triangle, another one is there, this is a right-angled triangle, there are four. Now, the diagonals are 5 centimeters. 5 centimeters by 5 centimeters. And this is 12 centimeters by 12 centimeters. The sides, opposite sides are parallel. This side is parallel to this side. And this side is also parallel to this side. And all the sides of a rhombus are what? Are equal. All the sides of a rhombus are equal. So now we are going to find the area. Area of a rhombus is equal to a half times the length of diagonal 1 times the length of diagonal 2. What are the diagonals? You can take any to be your diagonal 1. Assuming this is my diagonal 1, this one. This one is my diagonal 1, so I will say diagonal 1 is equal to 12 centimeters plus 12 centimeters. Diagonal 1 is equal to 12 centimeters plus 12 centimeters, which is 24 centimeters. So diagonal 1 is 24 centimeters. Now, how about diagonal 2? You need to find the length of diagonal 2 as well. Diagonal 2 is 5 centimeters plus 5 centimeters. This is my second diagonal. So it is 5 centimeters plus 5 centimeters, which is equal to 10 centimeters. So the length of diagonal 2 is 10 centimeters. Now I substitute into my formula. It is a half times diagonal 1, which diagonal 1 is 24. Which diagonal 1 is 24. So that is 24 centimeters. Times diagonal 2, the second diagonal is 10 centimeters. The second diagonal is 10 centimeters. So I reduce by 2, 1. 24 divided by 2, that is 12 centimeters. So area of the rhombus is 12 centimeters times 10 centimeters. 10 centimeters times 12 centimeters, which is 120 centimeters square. So that is the area of the rhombus. That is method 1, and that was this method was using the diagonals to work out. Now I'm going to show you the second method. Second method of how to find the area of aromas. A second alternative. A second method is now using the 4 right angled triangles. We can also find the area using the 4 right angled triangles. Those are the ones that are formed when the diagonals bisect each other. They end up forming 4 right angled triangles. 1, 2, 3, 4. Now, let me draw the rhombus again. This is the rhombus. This is the rhombus. And that is the rhombus. The opposite sides are parallel and all sides are equal. This side is parallel to this side. These two are parallel to each other. This is parallel to this, and this one is parallel to this one. Now it is 5 centimeters by 5 centimeters. Then here it is 12 centimeters by 12 centimeters. Now what I do, since all these triangles, when you look at all these triangles, they have the same height and they have the same base. These triangles have got the same height and they have the same base. So meaning that I can find the area of one triangle. Let me do extraction. I extract one right angled triangle. And this is my extraction. I've extracted one right angled triangle from the rhombus. And this one is what I've extracted. Its height is, I've extracted this one. Its height is 12 centimeters. The height is 12 centimeters. And the base is 5. The base is 5 centimeters. Now, I've said there are 3 methods we use to find the area of a rhombus. 1, you can use the diagonals of the rhombus to find the area. 2, you can use the 4 right angled triangles. You can use the 4 right angled triangles to get the area. How? By getting area of 1, you get the area of 1 right angled triangle. You realize that all these triangles have got the same base and the same height. When you look at the diagram, for this triangle the base is 5, the height is 12. For this triangle the base is 5, the height is 12. For this triangle the base is 5, the height is 12. For this triangle the base is 5, the height is 12. So they all have the same base and height. That means when I get the area of one of them, which is a half times base times height, and after getting that area, I multiply it by 4. Multiplying it by 4, I'm trying to get the total area of all the triangles which make up the rhombus. Then I would have found the area of the rhombus. So which is going to be a half times the base, which is 5 centimeters, times the height, which is 12 centimeters, times 4. I've said 4 represents the number of right angled triangles that make the rhombus. So by 2, 1, by 2, 6 centimeters. So I end up with 5 centimeters times 6 centimeters. There I'm getting the area of one triangle. Times 4 because the triangles are 4. So with 5 times 6, that is 30. Cm times cm, that is cm squared. times 4. When you multiply by 4, you are going to get 120 centimeters square. Now, we are getting, here we use diagonals, we got 120 centimeters square. Here we used the right angled, the 4 right angled triangles. We are also getting the same area. Different method. Now, I'm going to give my last method. This is my last method. This is my last method. My last method is going to look at, that is using the 2 isosceles triangles. Using the 2 isosceles triangles. Now, the last method is using the two isosceles triangles. And we are going to see them. So now we are using the 2 isosceles triangles. That is the last method we are looking at. Okay, let me draw the rhombus. This is our rhombus. This is our rhombus. That is our rhombus. We are using the same rhombus to work out area, but using different methods. Now this is we said the diagonals bisect each other, and as they bisect each other, they end up forming 2 isosceles triangles. This side is parallel to this side, and all the sides are equal. All the sides of the rhombus are equal. So it is 5 centimeters by 5 centimeters, 12 centimeters by 12 centimeters. And that is how it is. Now remember, we are finding the area using the 2 right isosceles triangles. And which are the isosceles triangles? There is this one. We have this one. You remember, an isosceles triangle is a triangle whose 2 opposite sides are equal, and its base angles are also what? Equal. Now, when you observe this diagram, this triangle, this one, is isosceles. Even this one is isosceles. 2 of the opposite sides are equal. 2 of the opposite sides are what? Are equal. Now I am going to find the area. So I extract one right angle triangle. You realize that all these right isosceles triangles will all have the same area. Why? Because they have the same base. All of them, their base is 10. 5 plus 5, we get 10. This one, its base is 10. Their heights are 12. Each of them is 12. Now what I do, I extract one isosceles triangle. I'm extracting this one. I extract it and draw it here. That is the isosceles triangle I've extracted. The height is 12. The height of that isosceles triangle is 12 centimeters. Remember the base. They said here it is 5 centimeters, and here it is 5 centimeters. That is the base. Meaning that when you add the two, the distance from here to here, you get 10 centimeters. But remember, the isosceles triangles are two, and they have the same base. So I'm continuing from this side. Continuing from this side. So now, since that is a triangle, area of a triangle is equal to a half times the base times the height. You get the area of one isosceles triangle. But since two isosceles triangles make up the rhombus, so you multiply by 2. 2 represents the number of isosceles triangles that make a rhombus. By the way, even if somebody decided to use this one, these two, maybe I'll try to use them and see. So now, which is going to be a half times our base, which is 10 centimeters, times the height, which is 12 centimeters, times 2. 2 represents the number of two isosceles triangles that form a rhombus. Two isosceles triangles both together and join form a rhombus. So meaning that to find the area, we can get the area of one isosceles triangle. Remember, this was an extraction. One isosceles triangles. You get the area of one isosceles triangle times 2. You will get the area of the rhombus. So by 2, 1. By 2, 5 centimeters. So you end up with 5 centimeters times 12 centimeters. That is after getting the area of the isosceles triangle, times 2. 5 times 12 is 60. Cm times cm is cm squared times 2. So you end up with 122 centimeters squared. And we're getting the same answer. So we have used 3 methods. But now, let me use if I use the other isosceles triangle, if I make another extraction. But of the same, okay, let us look at that same. And we are still looking at the same. So now, another alternative, but still using the two isosceles triangles. Now this time, the extraction I'm going to make is this. I'm taking this isosceles triangle, this one, if you can observe. If I draw it here, this is how it will look like. This is its height. That is the height. The height this time is 5 centimeters. If I took this as my extraction. Are we together? So now, this is 12 centimeters, and this is 12 centimeters. Remember, opposite sides are equal. This triangle is isosceles. Are we together? Two opposite sides of an isosceles triangle are equal, and its base angles are also equal. The base angles are the ones here. These are the base angles. So now, that means the base is running from this point to this point. And that is 12 plus 12 is 24. That means the base is 24 centimeters. But remember, I've said there are two isosceles triangles that make up this rhombus. This isosceles triangle and this isosceles triangle. You realize that they all have the same base and they all have the same height. So area is equal to a half. We are getting the area of the isosceles triangle times the base times the height. But since two isosceles triangles are joined to form a rhombus, so when we get the area of one isosceles triangle and multiply it by 2, we would have got the total area of the two isosceles triangles that form the rhombus. Remember, multiplication is repeated addition. So times 2. So I substitute, which is a half. Remember, I'm getting the area of the isosceles triangle. A half times the base, which is 24 centimeters, times the height, which is 5 centimeters, times 2. 2 represents the number of isosceles triangles that form the rhombus. So by 2, 1. By 2, 12 centimeters. So which is equals to 12 centimeters times 5 centimeters times 2, which is 60 centimeters squared times 2. 2 times 60, we end up with 120 centimeters squared. 120 centimeters squared. So that is what we have done with the rhombus. I think you have now understood all the 3 ways you can find the area of a rhombus. Thank you for watching this program. We meet next time.